Now in this lecture we are going to talk about next type of open addressing, which is quadratic probing. Now in case of quadratic probing, we are adding arbitrary quadratic polynomial to the index until an empty cell is found. So what does it mean? So here again we have three strings over here, and if we call hash function for these strings over here, we see that it's returning 2 in this case. So we are going to use quadratic probing to insert these strings to this hash table over here. Now for the first string, we don't have any problem. We are just going to insert it at the index of 2, because in this case at the index of 2 we don't have any elements, so we can insert it over here without any problem. Now after inserting this, we are going to continue to the next string. So in case of next string, we see that the output is 2, so we are going to check the index of 2. We see that it is occupied. So in this case, we are going to use quadratic polynomial over here to find an empty cell. So we know that the index of second string is 2. We are going to sum these 2 with the first quadratic polynomial over here, which is 1 square. So after summing them, we are getting 3. So we are going to check that if 3 is occupied or not. So in this case, we see that 3 is not occupied over here, so we are going to insert to the index of 3 over here. Now, in the third case, we are going to repeat the same process. So in this case, the index is 2. So we are going to sum up with the first quadratic. We see that after summing with the first quadratic, we are getting 3. But at the index of 3, we have another string over here. So this means that we need to continue to the next quadratic. Now in the next quadratic, we have 2 squared. So this means that we are going to add 2 with the 2 squared. So in this case, after addition, we are getting 6. So this means that we are going to check that if the index of 6 is occupied or not. So we see that in this case, it's empty. So we can successfully insert this string to this index over here, which is 6. Now, this is how it continues until we find the empty cell in our hash table. So every time we are using the quadratics polynomial and adding it with the index that we are getting from the hash function and looking for the empty cell in the hash table. So as soon as we find the empty cell, we are inserting this string to this hash table over here. Now, based on this logic, let's head over to Java and create quadratic probing in practice. So here we have created quadratic probing file, and inside this file we have declared our class like this. So basically this is same as with the linear probing. So that's why I'm not doing everything from beginning over here. So here basically first I have imported array list. Then we have created our quadratic probing class like this. Then we have declared our hash table, which is the string type of array. Then, as we did before, we are declaring use cell number as an integer type. Then inside constructor, we are creating the hash table with the size that comes from the parameter. Then we are setting use cell to the 0. Now then, we have created a hash function that we have created before. So basically this hash function over here is the same hash function that we have created in our previous lecture. If you want to know more detail about this function, I advise you to go back to the previous lectures in this section. So the next method that we have created over here is get load factor. So by using load factor, we are calculating that if we want to create a new hash table or not. Then after this method, we have created rehash keys. So by calling this method, we are creating a new hash table with the size of 2x and inserting all elements that we have in our previous hash table. Now after this method, we are going to create insert key in hash table method over here. So as you can see over here, we have created display hash table over here as well. So display hash table method is responsible for displaying hash values into the console. So this is just helper method over here. Now here, after rehash method, I'm going to declare our insert method like this. So it's going to be insert key in hash table. So as a parameter, it's going to take one parameter. So this parameter will be the type of string and the parameter will be vert. Now inside this function, the first thing that we are going to do, we are going to declare load factor, and we are going to get load factor by using this load factor function over here. This variable will be the type of double. So it's going to be load factor is equal to get load factor. So by using this function over here, we are getting load factor. Then based on this one, we are going to call rehash function, or we are going to insert this new string to the hash table over here. So as we said before, if load factor is greater or equal to 0.75, this is according to the Java documentation, then in this case, we are going to call rehash keys for this string over here. So it's going to be like this. Rehash keys. So as a parameter, we are going to pass this word that we are receiving from this parameter over here. Now in the else condition, if this is not the case, we are going to insert new value to the hash table. So as we said before, the first thing that we are going to do over here is we are going to calculate the index by using hash function. So integer index will equal to mod ASCII hash function. So we are going to call it for the word that we are inserting to the hash table, and second parameter will be the hash table dot length. Now after doing so, we are going to create a new variable over here, which will be the counter, and we are going to set it to 0, because in case of quadratic probing, we are going to use this counter as a quadratic over here. So it's going to be like this. So then after doing so, we are going to create a loop over here. So this loop will start from the index that we have calculated by using hash function. Then it's going to continue until I is less than index plus hash table length. Now in each iteration, it's going to be increased by 1. Now after doing so, we are going to calculate new index. So integer new index will equal to index plus, so this is the index that we get from the hash table, plus, so we need to use quadratics over here. So I'm going to put it like this, counter multiplied with counter to get the quadratics. Then it's going to be used mod hash table dot length. Now with this, we have successfully calculated new index. Now we are going to check that if the value that's located in this new index in hash table is null, we are going to insert it to that cell. Otherwise, we are going to continue to loop through the hash table to find empty cell over here. So it's going to be like this. If hash table dot hash table with the new index is equal to null, in this case, we are going to put it like this. Hash table with new index is equal to the word that we want to insert to the hash table. Now after doing so, we are going to print out saying that successfully inserted this word to the hash table. So in this case, I'm just going to call print statement like this. Word has been inserted successfully. Now after putting this message, I'm going to put a break over here because we don't need to continue to the loop because we have already inserted over here. Otherwise, we are going to continue to the next cell. So in the else condition, I'm going to put that this index is already occupied. We are trying to put in the next index. So I'm just going to copy this print statement from here instead of retyping it over here. Then inside this one, we are just going to put new index is already occupied, trying next one. Now after doing so, we are just going to increase counter, but because in each iteration we are going to increase it by 1 to see the result. Then at the end, we are going to increase used cell number by 1 because we have inserted a node to this hash table over here. Now with this, we have successfully implemented insert key in hash table in case of quadratic probing. Now let's see how this is working in practice. So here inside main class, I have created an instance of quadratic probing class over here, and we are creating hash table with the 13 cell over here. Now as we did before, I'm going to insert the words that we have inserted in case of linear probing. So in this case, it's going to be like this. So if I insert these variables over here, and after inserting, if I print out the display hash table, we will see that if we have inserted elements to these strings to this hash table or not. So if I run our code, now after running, you see that D has been inserted successfully, quick has been inserted, brown has been inserted. Then after that, it says that 8 is already occupied, trying next one. So then Fox has been inserted successfully, and it continues like this until we have inserted all elements. Now if you look at the hash table over here, you can see that all elements are inserted successfully over here. So this means that our insert method in hash table in case of quadratic probing has been successfully inserted. Now with this, we have completed quadratic probing as well. Now you might be interested why we are not implementing search and delete method in this case, because in this case search and delete methods are same as the one that we have in our linear probing. So that's why I'm just skipping them. So in this case, you can use same methods in case of searching and deletion. So this is all for this lecture. So hopefully everything is clear about quadratic probing implementation. So see you in the next lecture.